So let's start the first one. That is for logistic regression, how to work on the logistic regression. So just I'm recapping once again the logistic regression before doing the practical implementation of logistic regression. So now logistic regression means you are going to apply the linear regression first. That is y hat is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Okay. So on up to beta n xn, right? So you're going to consider like this, and from this you're going to calculate the probability, that is e to the power of y hat divided by 1 plus e to the power of y hat. Y hat means nothing but whatever the equation you have got using the linear regression, that value you are going to substitute here, and you are going to get the probability. And based on the probability, you are going to take the threshold value, and based on the threshold value, you are going to either convert this one to class 0 or class 1 based on the threshold value. By default, the threshold value is 0.5. So here, whatever the probability is greater than 0.5, it will be converted as class 1. Whatever the probability less than 0.5 will be converted as class 0. So this is the one which we have discussed in the last class of logistic regression. So let's see the same thing. Now here, I'm going to work on the data set. So first I'm going to import NumPy, Pandas, Matplotlib, Seaborn, and along with the warnings. If you want to ignore the warnings, means you can import the warnings, or otherwise as per your choice. If you want to ignore, means just ignore that. Right? Now here the data set. I'm having the data set. What is the data set means? This data set belongs to diabetic data set. Whether the person will get a diabetic or not, yes or no. Whether the patient is a diabetic or not. Okay. So here the business problem. What is the business problem is we have to identify whether the person is a diabetic or not with the maximum accuracy. That is our business problem. We have to predict the business problem. What is the business problem? First one is we have to predict whether the person is a diabetic or not. Based on this, based on the input variables, we have to predict whether the person is a diabetic or not. So we have what is the business problem is create a predictive model, create a predictive model which can predict whether the person is diabetic or not, right? So create a predictive model which can predict in terms of whether the person is a diabetic or not based on the input variables. This is the business problem where we have to predict with maximum accuracy. What is our target is accuracy. Accuracy is the target in this case. So here we have to predict with respect to maximum accuracy. So here I'm having the input variables like glucose, blood sugar, skin thickness, insulin, BMI, DBF, and age, and all these things. And based on which I have to predict whether the person is having a diabetic or not. So if I observe the info, total it is of 768 records. This is a base 768 records of 9 columns. Total 9 columns are there, 768 records, out of which 8 of them are input variables and 1 of them is output variable. So now first I'm going to check the output variable. What are the unique values? Whatever the output variables are there, what are the unique values means zeros and ones, means it is a binary classification problem. So from this, I'm going to conclude my data is binary classification problem, and I want to predict whether the person will get a diabetic or not. So that is the reason, if you observe the diagram of the CRISP-DM methodology, if you see the CRISP-DM methodology diagram, in the diagram very clearly they'll write with respect to double arrow mark. Here you'll see the first one will have the double arrow mark in every stage. So whatever the diagram you take, everything are same, one and only same. Okay, this is the standard one. Okay, so CRISP-DM methodology, if you observe the starting one will have the double arrow mark. Double arrow mark meaning is We have to understand the business problem. Along with that business problem, related to that business problem, whatever the data understanding is required. In the data, if you're not, for example, my business problem says that like this, predict whether the person is having a diabetic or not. But if whatever the data set I have taken, in that data set, for example, these unique values, instead of 2 unique values, I have got third one. Some third number also is there. Means some data was wrongly given. What is that third one? Third category. Some category should be there, right? Either zeros or ones means zeros means the person is not having any diabetic. Yes, one means yes, he is having the diabetic. 0 or 1. Now I'm having the third category means somewhere data is wrong. So I have to identify first what I'm going to do. I'm going to take the DF of outcome. The DF of outcome is equal to 2, and I'm going to identify which are the records. If only one record or 2 records are there, means instead of entering yes or no, they have entered something, so that I can understand. In that way, I can understand and I can feel that one as a wrongly inputted data, and I will do the data cleaning. For example, more number of records are there. More number of records, they'll not do the mistake, right? If 1 or 2 records means randomly while entering, they have made a mistake, printing mistake, I can understand. Continuously mistakes are there, miss. For example, instead of earlier, here I have written the create a predictive model. Instead of create a predictive model, create a predictive model. I have not given the space. Create a, so here if you read this one, you'll feel this one as a single word. And you will read this one as a single word. And you'll understand, okay, so, though I have uploaded the same notes for you, you'll understand that, okay, sir has in mistake, he has written this one, he has forgot to give the space. You'll feel in this way. For example, everywhere I'm doing the same thing, miss. 1 or 2 miss, okay. Then we'll understand, okay, some mistake is there. But every time I'm doing the same miss, then what you'll understand? In what case you'll understand? So similarly, here also the same. In the given data, the output variable consists of 2 categories. And these 2 categories are linked with the whatever the business problem. My business problem is to predict whether the person is having the diabetic or not. So to be more simplified, this particular data set, whatever the data set presently I'm working, it might be a simple data set, but in the real life, for see, many students commonly, what they'll ask, commonly. So many students, whatever the project they work, that is easy for them. Whatever the unknown data, unknown project is there, that will be difficult for them. Whatever the project they have worked earlier, it will be very easy. And this is easy project, we have already completed. They'll feel in this way. Whatever the new project they'll see, everything they'll feel as difficult. The reason behind this is, here the project, the others has explained, someone has explained earlier to them, or they have practiced on that, or they have understand that, and they have worked on that. Here, without understanding anything, directly they're going to load the data. Now they'll start with loading the data, and directly they want to work. Within first, by seeing the question, within 5 minutes, they want to load, and within 10 minutes, they want to complete the EDA. And in the 11th minute itself, they want to apply the machine learning algorithms. That is the reason why they will miss with respect to unknown projects. In unknown projects, they will get an errors, or they'll ask multiple questions, or they'll not find anything. Sir, while doing this project, it is easy, sir. Whatever you have explained in the class, it is easy. But when we are working on a new project, it is getting difficult. Means they'll not even understand the business problem. They don't want business problem. They don't want data understanding. Without these two, what they want is load the data, clean the data. Directly apply the data pre-processing. The moment you give the project, and if you share that, first, if you say some project means, so please share the data sets. First, they'll ask, please share the data set. Okay. If you share the data set, the moment you share the data set, immediately import pandas as PD, pandas.read CSV or pandas.read Excel. And they'll start doing the data pre-processing. They'll not even work on what is data understanding, what is business problem. That is not important for them. Directly, third stage is important. Third stage is important, and fourth stage of machine learning algorithm, applying every time applying the algorithm and getting the output final accuracy code is answer only important. And after that, they realize, once they understand the business problem, they realize, oh, in this case, we should not do like this. We have to do in that way. Why we have to that way, miss? That is the reason. Business problem is the reason. Again, they'll come back from this stage to this one. That is the mistake which generally most of the students will do at the end. Who are already familiar with machine learning in this class might be. Some of the students are new to machine learning or anything, whatever it is. At the end, everyone are common, right? Now might be different, but at the end, everyone are common in this class. Everyone will do the capstone project. While doing the capstone project, this is the problem. When in the capstone project, I'm going to share you a new data set, completely unknown data set for you, which you are not familiar in your entire life. That at the time, you'll ignore this business problem. But most of the understanding will be done here only. This is one of the most important step. If this is miss, remaining everything is waste. Okay, but students will not have that much of interest on spending this one. They'll have more interest on spending on this one, which is the wrong way of doing the project, basically. Okay, remember, in the real after once the all the machine learning algorithms are completed, you are going to apply the capstone project. While applying the capstone project, and you want to apply on a new data, completely on an unknown data, or first time you are doing on that particular project, means focus on the business problem very clearly. Without doing this, don't jump into directly into this. Automatically, again, you have to come back and total time will be wasted. Double time you have to spend. You will think intelligent and you will feel that you are intelligent and directly will work. But later you will feel what is the mistake you have done. Again, you will come back to that position only. Okay. Maybe by luckily 1 or 2 projects you may complete in that way successfully. But in real life, not even single project also you can't complete in the real life without understanding the business problem. Here for this data set, if you don't understand the business problem directly, if you do completely coding and everything miss, okay. Because this is a simple projects, right? Now here, we have to understand what is meant by this glucose level, what is meant by blood sugar, what is meant by skin thickness, and what is meant by insulin, what is meant by BMI, what is meant by diabetics pedigree function, and with respect to age, and finally outcome. And in the outcome, what type of output I'm having in the output variable? What are the categories I'm having? Zeros or ones. Here, zeros and ones I'm having. And here I'm having with respect to the data set, where in this data set, if you observe, I'm having with respect to continuous variable. BMI is a continuous variable. DBF is a continuous variable. Age is a continuous variable. Insulin is a continuous variable. Skin thickness is a continuous variable. Blood pressure is a continuous variable. Glucose is a continuous variable. Now, whether this one is a continuous variable or whether it is a discrete count variable. So otherwise, let us understand what is glucose. Glucose, whether it is a continuous variable or discrete variable. So just how to identify whether it is a continuous or discrete means, first you have to understand what is meant by glucose. Just type in the Google. If you don't know miss, you have to research. If you're already familiar miss, well and good. If you don't know, you have to check in the Google. For example, some people don't know what is meant by blood pressure. BP, generally BP, which is the normal value. Normal value means 120 by 80. What is 120? What is meant by 80? What is meant by 120 and what is meant by 80? What is upper value? What is lower value? They know what is meant by normal BP means 120 by 80. Only that number they know. What is above value? What is below value? If upper value is more means what happens? If below value is more means what happens? Sir, we are not doctors now. No, though we are not at doctors also, still for our project, whatever we required in this one of the variable that word is there means we have to understand for that. Okay. And then we have to work on that. Is that clear? And now here describe function. I'm going to use the describe function. And from the describe function, I'm going to understand what are the minimum values, maximum values, and what is the average values, all these things. And next using the heat map. From the heat map, I'm going to identify, is there any collinearity problem? Is there any collinearity problem? So collinearity problem, I'm going to check between the input versus input variables. And at the same time, I'm going to check between the output variable versus input variable. So if I take this one, these are all the input variables and this is the output variable. And if I see the correlation between the output versus first input, 0.22, glucose versus outcome, 0.47, blood pressure, skin thickness, insulin, BMI. And like this, I'm having for each and every column. And if I observe clearly here, I'm having with one of the variable like first variable and first, second, third, fourth, fifth, sixth, seventh, eighth input variable. These both of them are having a correlation of 0.54. Right? So here, whichever is having light orange color, that is having the high correlation. The lighter the colors, the higher the correlation. So within the given data, which is light colors means this is light color. These are all light colors. And after that, this is light color. And when compared to this is somewhat light color. Okay, this is light color. So like this, we are going to identify whichever is having the high correlation. Out of all of them, this is having somewhat comparatively high correlation between X1 versus X8 variable. Between two independent variables, we are having a correlation more than 0.5. So this we are going to observe from this. And next, we are going to do the data pre-processing. In this, missing values are completely zero. No encoding is required. For the given data set, there is no encoding. And I'm going to separate the outcome and I'm going to take the outcome variable like this. That is X and Y. And then I'm going to apply the train test split. And I'm going to take some random state number. I'm going to fix some random state number, anything of your choice. Now, the question, many of the students will ask the common question here, what is the best random state number? Today, I will show you that one also. That code also will do that one. How to identify the best random state number. Right? Next, modeling. In the modeling, what we have to do? First one is we have to import the model ML algorithm and we have to save that one in a model name. And after that, we are going to fit on the X train, Y train. What we have done in the linear regression, same to same. Whatever we have done in the lasso regression, same to same. Whatever we have done in the ridge regression or whatever we have done in the elastic net regression, everything is same. First step, we have imported. Second step, we have saved that one into a model. And third step, fit on the X train, Y train. Once it is done, we are going to predict on X train. We are going to predict on X test. Why we are predicting on X train and X test separately? Because to find the train accuracy, test accuracy, both the accuracies. Not only test, we have to check even train also. Because my model is a overfitted or underfitted also, we have to check. So for that, what we are going to do? We are going to predict on the X train, predict on the X test. And from that, you are going to calculate the train accuracy, test accuracy, and CV score. Now I have got the train accuracy of 77.19, test accuracy of 82.46, and cross validation score of 76.95. 76.95. So this is the cross validation score where it is a good model. Now confusion matrix. Now as I have told you how to take the confusion matrix. Now if you remember in the last class coding part, last class means yesterday's theory part we have done. Before to that in the lasso regression, in the lasso, in the ridge or in the elastic net, if you observe these three algorithms, first one is I have imported, import, and I'm going to save into a model, fit on X train, Y train. There is no difference in this. Using your model name, model.predict on X train, model.predict on X test. There is no difference in this. Up to here, it is common. Now coming to the evaluation, in the evaluation, earlier we have calculated R square or RMSE. Here we are going to calculate the accuracy, the word accuracy. How to calculate the accuracy means from sklearn.metrics. From sklearn.metrics, you are going to import the accuracy score. From sklearn.metrics, you are going to import the accuracy score, and the accuracy score of Y train, Y pred train means these are the two values. This is the actual value and this is the predicted value. So you are going to give the actual value versus predicted value. It will identify this is the actual Y and this is the predicted Y. In the actual Y, for example, let us take like this. This is the Y pred test. What is Y pred test? Means predicted on the X test. So let us see these values separately. Let us check. So these are the values. Now Y test. This is the original data. This is the test data, predicted data. This is the original data. Okay, I'm having the original data and predicted data. Now here I'm now what it is going to do? First record. 1 and 1. Second record 0 and 0. Correct. First record correct. Second record correct. Third record, fourth record, fifth record. Like this, it is going to identify total how many records are correctly classified. That is called as accuracy score. Right? In the last class, we have seen the example, right? I have shown you the example how to calculate an accuracy score by taking the some data points like this and predicted values. And I have told you what is meant by accuracy score means how many data points are correctly predicted. That is called as accuracy score. You are predicting on the X test, whatever the X test is there, X test data you are predicting using your model. Whatever the model you have predicted and you have got the values called as Y-pred test. These are the predicted values. These are the predicted values. Now, what is the original values? What is the original values? Original values are Y-test is the original values. Right? Now you are comparing between your Y-test versus Y-pred test. Similarly, Y-pred train versus Y-train. Right? You're using your model, you are going to predict the values, and whatever the values are there, you are just comparing. So in this way, you are going to calculate the train accuracy, test accuracy separately. This is the only change because you are having here accuracy score. In the earlier coding, just let me open in front of you the previous one, whatever we have done in the regression, in the last regression, that is ridge regression or elastic net regression, whatever it is. Let me open the ridge regression. In the coding part, data pre-processing is common. There is no difference. In the coding part, what is the difference between this one versus this one? Let us keep both of them side by side. So here, what is the difference between here? From sklearn.linear model, import the ridge. From sklearn.linear model, import logistic. Ridge underscore base is equal to default parameters. Log underscore default is equal to logistic regression default parameters. Here ridge regression, here logistic regression. Fit on X train, Y train. Here also you are going to fit on the X train, Y train. If you are interested to see the intercept and coefficients, here we are going to see the intercept and coefficients. Here no need to see the intercept and coefficients. And prediction on the X train, predict on X train. Predict on X test, predict on X test. What you are predicting? Using your model name. What is the model name you have taken? Using your model, model.predict on X test, model.predict on the X train. Similarly, whatever the model is there, model.predict on X train, model.predict on X test. So up to predictions also same to same. There is no difference. Now here what we have done is we have calculated the R square here. In this case, we have calculated the R square. Whatever the R square is there, we have calculated the R square. In this case, what we are going to do is accuracy score. We are going to calculate the accuracy score. So how to calculate the accuracy score means accuracy score, we have to give the original value along with the predicted value. Then it is going to compare between both of them, how many records are same. And once it is calculated, the train accuracy, test accuracy separately and cross validation score. How to calculate the cross validation score? From sklearn.model selection, import cross validation score. And you are going to write your model. After model X comma Y comma CV is equal to 5 dot mean. Same to same. Whatever the model name comma X comma Y CV is equal to 5 and dot mean. So here it is, we are going to write the scoring is equal to accuracy. Scoring is equal to accuracy means it will identify which is the best. It is going to calculate the cross validation based on the accuracy wise. Every time it will calculate the accuracy. Is that clear, guys? Got the point? Voice is not audible. Guys, others, can you please confirm? Is my voice is clear? Yes, clear and right. Done. Ganesh, can you please re-log in? Okay. So I'm having with respect to accuracy score. Once accuracy score is calculated, I'm going to calculate the confusion matrix. Now, how to calculate the confusion matrix means from sklearn.metrics, import the confusion matrix and confusion matrix of Y test versus Y-pred test. whatever the confusion matrix you want, original data, predicted data you have to give. Then automatically you are going to get the confusion matrix. Out of confusion matrix, it is going to take the actual this side, predict this side. And first it will take the 0 and 1, 0 and 1. The first cell indicates actual 0, predicted 0. Second cell indicates actual 0, predicted 1. This cell indicates actual 1, predicted as 0. This cell indicates actual 1, predicted 1. And you are going to get the output in this way. These are the 4 values. Total 4 values. Now, how to get the confusion matrix means from sklearn.metrics, import the confusion matrix. And within the confusion matrix, you have to write y test versus y pred test. Right? Is that clear? Now, sir, okay, can we calculate this one manually? Let us try that one also. Here I'm taking a y test dot values. So now now here you are having the original y pred and you are having the y test. Can anyone calculate and tell me how many records are correctly classified or wrongly classified? Anything is okay. So just a shape. What is the shape of this one?